Black holes are among the most mysterious and fascinating objects in the universe. They cannot be seen directly, yet their presence can shape entire galaxies. In this video, we'll explore what a black hole really is, how it forms, and why its gravity is so extreme that not even light can escape. In this image, the curved lines represent how gravity extends outward from Earth. The closer you are, the stronger that pull becomes. Now, if you launch an object upward, it needs a certain speed to escape Earth's gravity completely. The speed is called the escape velocity. The yellow arrow shows that idea, an object moving fast enough to break free instead of falling back. For Earth, that speed is about 11 kilometers per second, or roughly 25,000 miles per hour. In this image, we're comparing the gravity of the Moon and the Earth. The Moon has much less mass than the Earth, so its gravitational pull is weaker. You can see that represented by the smaller curvature and the shorter arrow. Earth, on the other hand, has much more mass. The greater mass creates a stronger gravitational pull, shown here by the deeper curvature and larger arrow. The key idea is simple. The more mass an object has, the stronger its gravity, and the gravity increases, the escape velocity also increases. When gravity becomes extremely strong, the escape velocity continues to increase. In this image, we are now considering an object so massive and compact that the escape velocity reaches the speed of light. The beam of light showed here represents that idea, light trying to move away, but being pulled back by gravity. Since nothing can travel faster than the speed of light, once the escape velocity reaches that limit, nothing, not even light, can escape. This is a critical point where an object becomes a black hole. A black hole is defined as a region of space where gravity is so strong that nothing can escape from it, not even light. In this image, the bright ring surrounding the dark center represents matter that is being pulled inward by gravity. The boundary around the black hole is called the event horizon and marks the point of no return. Once anything crosses this boundary, it cannot escape back into space. The dark central region represents the interior of the black hole, where our current understanding of physics is limited. This is the point where an object has become so massive and compact that escape velocity has reached the speed of light. The event horizon is a boundary that surrounds a black hole and marks the point of no return. In this image, it is shown as the glowing edge around the dark central region. As matter or light approaches this boundary, gravity becomes so strong that escape is no longer possible. Even if something were moving outward at the speed of light, it would still be pulled back. Once an object crosses the event horizon, it cannot return to the outside universe. From that point on, it is inevitably drawn inward toward the center of the black hole. The singularity is at the center region of the black hole, represented here by the dark center. It's thought to be a point where matter is compressed into an extremely small volume, causing density to become extraordinarily large. However, this is where our current understanding of physics reaches its limits. The laws we use to describe gravity and matter break down under these conditions, so the true nature of this singularity remains unknown. In this image, we compare how mass affects the curvature of spacetime. On the left, the sun creates a gentle curve in space, which is what keeps our planets in orbit. On the right, the black hole produces an extreme curvature, forming a deep gravitational well. The greater the mass and the more compact the object, the stronger this curvature becomes. In the case of a black hole, the curvature is so severe that everything is pulled inward, and nothing can escape once it crosses the event horizon. In this video, we've seen how gravity can become so strong that it completely changes the nature of space itself. A black hole forms when an object becomes so massive and compact that escape velocity reaches the speed of light, creating a boundary known as the event horizon. Beyond that point, nothing, not even light, can escape. While black holes remain some of the most extreme objects in the universe, they also help us better understand gravity, space, and the limits of physics. Thank you for watching, and stay tuned for more explorations of physics and the universe.